Affinity propagation model. So, what is that model? In our previous section, we have learned about clustering and many algorithms like k plus plus, k means, and your shift mean algorithm. So now we are going to learn a new algorithm for clustering, and that is your affinity propagation model. So this is your algorithm for clustering. Now, what is special in that model? So affinity propagation is a clustering algorithm that does not require us to specify the number of clusters beforehand. So in our previous algorithms which we have learned for clustering, we have seen that we require the number of clusters beforehand. So before using that algorithm, we need the number of clusters. But in that model, we are not requiring the number of clusters before using that algorithm. So this is the basic difference, and that's why we are using this. Now, what are other specialties present in that model? That is your generic nature, because we can use this model for any purpose, and it is not depending on any parameter like. And next is your simplicity of implementation, since it is we are not specifying the number of clusters, and its internal working is also simple. It is simple to use, so that's why this model is very important and very good model for clustering purpose. Okay, so now what is special in it? What is the internal working of that model? So it find out representatives of clusters called exemplars. So in our previous algorithm, we have seen that we have found the location of centroids, and we were updating their location. But in that model, we are finding the representatives of clusters, and these representatives are known as exemplars. Now, what we are using for finding out these exemplars, we are using a technique that is known as message passing. So, what is message passing here? We start by specifying the measures of similarity that we want it to consider. So, first we specify the measure of similarity, that is the similarity metric that we want to form cluster on the basis of that. It simultaneously considers all training data points as potential exemplars. It then passes message between the data points until it finds a set of exemplars. So to find set of exemplars, optimal set of exemplars, we have to pass messages, and that is your message passing. Now how message passing will be performed? So let's see. The message passing happens in two alternate steps called responsibility and availability. Now what are these two steps? Responsibility refers to the message sent from members of the cluster to candidate exemplars. So responsibility refers to those messages which will be sent from members of the clusters to candidate exemplars, that is exemplars of that cluster, indicating how well suited the data point would be as a member of this exemplars cluster. So that member will indicating its own identity, that how it is well suited to be the member of that cluster. And next is availability. So availability refers to the message sent from candidate exemplars to potential members. It is in different direction. Message will be sent from candidate exemplars to potential members of that cluster. And what is that indicating? That message will indicate how well suited it would be as an exemplar. So in this, exemplar is proving its identity, exemplar is showing its identity to the member. While in case of responsibility, members of that cluster will be showing their identity to the exemplar. So both messages will be sent, and that is your message passing process in that model. Now it keeps doing this until the algorithm converges on an optimal set of exemplars. So finally we will find optimal set of exemplars using that method. There is also a parameter called preference. Now what is preference? Preference is a parameter that controls the number of exemplars that will be found. So preference is controlling the number of exemplars. If we choose a high value, then it will cause the algorithm to find too many clusters. So if you are choosing high value for the preference parameter, then it will cause algorithm to find too many clusters. While if we choose a low value, then it will lead to a small number of clusters. So number of clusters will depend upon that parameter, that is your preference parameter. Next, a good value to choose would be the median similarity between the points. So now let's use this model to find subgroups in the stock market. Now stock market, that is the related to your financial data. So we have to find the subgroups in stock market. So we will use that model. Now subgroup is denoting your clusters. So you are using that clustering model to find clusters for the data present in your stock market. So how to implement that model we will see now using Python language. Okay, so let's see it.